Welcome to EducAgent Studio, where a crew of AI agents help us teach and you learn with ease. Here's the problem we'll solve today. Here's the matrix S. Notice its ones build up along the lower triangle. And here are the unknown vector y and the right-hand side b we want to match. The task is to find y so that sy equals b. Pause and think. How would you use the structure of S to make this easy? If you don't know yet, you'll feel the satisfaction of discovering it soon. Break S into its three column vectors S1, S2, and S3. These are the building blocks for B. Writing Sy as a linear combination, B equals y1 times S1 plus y2 times S2 plus y3 times S3. Entry-wise, the linear combination gives a simple lower triangular system. B1 equals y1, B2 equals y1 plus y2, and B3 equals the sum of all three y's. From the first equation, we immediately get y1 equals b1, which is 1. From the second equation, subtract y1 to find y2 equals 4 minus 1, which is 3. Finally, the third equation gives y3 as 9 minus the sum of the first two y's, so y3 equals 5. Putting the entries together, the solution vector y is 1, 3, 5. Think of S as computing cumulative sums. Each B entry is the sum of the Y entries up to that position. Inverting cumulative sums gives the first differences formula. Each Y is a difference of consecutive B's. Applying the formula to the numbers gives Y equals 1, 3, 5, the differences of B. Let's recap the short key steps. First, we wrote down the column vectors of S. Then we solved the lower triangular equations by forward substitution. Finally, we recognized S as cumulative sums and inverted it by taking differences. Thanks for watching, and hey, stick around for the next video to see more clever matrix patterns and tricks.